This lecture is going to cover calorimetry and basic calorimetry equations and solving for those problems. You will want to make sure that you do have a calculator. So once you have that calculator set, let's go ahead and get started. Before we begin with any calculations, we have to understand what calorimetry actually is. So calorimetry is going to be the process of measuring the amount of heat or the amount of heat that's absorbed or the amount of heat that is released during a chemical reaction. So when we see reactions occurring, some form of heat is going to be exchanged, whether that is absorbed into the reaction or it is released to the environment. And one thing that you want to keep in mind is that there is a unit that we will be measuring that heat in and measuring that energy, and that is in joules or kilojoules. So you will see both of those written out. You will see them written out either as a J or as a KJ. Okay, so either one of those, and we'll talk about how to identify which one of those you'll be using, and then eventually we'll go into converting from one of those units to the next in your answers, but we'll get to that later on. Another term that you need to be familiar with when doing calorimetry problems is specific heat. You may have remembered specific heat being done when you talked about stuff in biology, specifically water, and that water has a high specific heat. And we'll talk about what that means in a second, but specific heat in general is the amount of energy that it's required to raise 1 gram of a substance by 1 degree Celsius. So let's kind of talk about what that actually means. I'm going to try and clean this up for you a little bit here. So grams times degree C is what that says. So if I had 1 gram of water and I wanted to raise the temperature of that water, let's say from 50 degrees Celsius to 51 degrees Celsius, so I'm taking my 1 gram of substance and I want to increase it by 1 degree Celsius, it's how much energy needs to be put into that system to make that change in the temperature. One thing to keep in mind, and you'll see this on the next slide as well, is when we are doing equations, specific heat is going to be the variable C. So you'll want to keep that in mind as well. So this table is just showing you the specific heat values for various substances. The top 3 here with the water, the steam, and the ice are ones that we will see quite a few times. I might write those down just so you have those as reference because you will need them when you're doing the worksheet. So water has a specific heat value of 4.184 joules per gram degree Celsius, which is very high. Water has a high specific heat, so that means that it takes a lot of energy for us to change the temperature of water. So any of you that have boiled water know that it takes a long time for that water to boil. And that's because water resists the change in temperature, and that's significant for us in terms of living things because our cells are made of water and we don't want our cells changing their temperatures dramatically and having it take not a lot of energy for that to happen. So water has a high specific heat. You'll notice that the specific heat of ice and steam are both almost half of what it is for water. So it doesn't take as much energy for me to change the temperature of ice, so to melt it, as it does for me to change the temperature of liquid water. Also with steam, so in its vapor form, it doesn't take as much energy for me to change the temperature of vapor as it does for liquid water. You'll also notice here that I gave you some numbers for solids, so this is just to kind of give you a reference point in terms of water and how it's different than others. So aluminum has a specific heat of 0.897. That is actually pretty high for a metal. Metals usually melt pretty easily. So that's actually a higher value than your others. So if you're looking at something like iron, iron has a lower specific heat. So that means that it melts and it changes temperature, I guess we should say, a lot easier than aluminum does. So just think of it as that. The numbers that have a higher amount or a higher specific heat means that it takes more energy to change its temperature. Something that has a lower specific heat value is going to change temperature with a lot less energy. All right, so let's get into looking at what our calculations are going to be. The equation that you are going to use is Q equals mc delta T. So this triangle here is the Greek letter delta. So you'll see that a few times throughout the year, so we'll talk about what that means when we get down to delta T here. So Q is going to be our variable for energy. So in these equations here that we're doing today, you will be solving for Q. We'll look at how to solve for the other ones later on in the unit. But so we're solving for Q, we're solving for the amount of energy required. M is our mass, our unit on that is going to be in grams. C, we just talked about, is our specific heat. Our unit on that is joules per gram degree Celsius. So you can kind of ignore this little box here. It's just when I transferred it over, it came up there. So you can look at how that's written on your other slides. And then delta T means the change in temperature, and we're going to use degrees Celsius in this. So our little delta here means change in. So anytime you see the triangle, you see the delta, it means the change in whatever the variable is. So what we're looking at here with our change in temperature is we're looking at the difference between the final temperature and the initial temperature. So we're looking at the difference between those. So what we're actually going to do is do final minus initial. All right, so an example problem. I would write down the problem, so if you want to hit pause and come back to it. How much heat energy is required to raise the temperature of 55 grams of water from 25 degrees Celsius to 28.6 degrees Celsius? The specific heat of water is 4.8 joules per gram degrees C. So first thing, I just want you to get in the habit of writing out your formula that you're going to use. Q equals mc delta T. So we are solving for Q, so that is our question mark. Looking at our equation, our M is our mass. Remember that that is found right here, so that's 55.0 grams. C is our specific heat. That's given to us right here in the problem. So the specific heat will be given to you. That's not a value that you need to memorize. 4.18 joules per gram degrees C. And our last variable is our change in temperature. So if you're looking here, we do have two temperatures. We have 25 and 28.6. So we're looking for the change. How much did my temperature change? My temperature changed by 3.6 degrees. So I got that by taking my 28.6 and I subtracted 25, and that gives me 3.6 degrees Celsius. Okay, so now all we do is we plug it into our new favorite equation listed right up here for us. So Q equals 55.0 grams times 4.18 joules per gram degrees C times 3.6 degrees C. Now you're probably wondering, why is she writing all these units out? Now, one thing I want you to keep in mind is that as we start doing different values and looking at equations that maybe everything doesn't match up, you're going to have to be aware of your units. So you've already heard me say this a few times, but you're going to hear me say it throughout the entire year, is you need to keep track of your units to make sure that they match up and that they cancel. So what's going to happen here is See, I have grams in 2 spots. Those are going to cancel. I have degrees C in 2 spots. Those are going to cancel. The only unit that I am left with at this point is joules. And if you go back, when we're solving for Q here, I want my units to be in joules. So I'm left with the unit that I want. So this is a good idea, or a good thing. So go ahead and pause the video, see if you can do that math, and then come back and we will look at the answer. So when you get this, you should end up with a value of 827.64, and your units are joules, because that just carries down with it, okay? So making sure that you are writing out the units on these. When you are solving for Q, that is always going to be your units. All right, next problem. A 40.0 gram sample of ethanol cools from 50 degrees Celsius to negative 30 degrees Celsius. Calculate the energy released by the ethanol. The specific heat of ethanol is 2.46 joules per gram degree Celsius. If you feel like, hey, maybe I want to try this on my own, go ahead and pause the video now. Try it on your own and come back, and I will work through the problem with you so you can double check, make sure that you did it right. If you still want to work through a problem with me, go ahead and follow along at this point right now. So equation that we need to use is still going to be Q equals MC delta T. Now, looking at this, if I go through and I start listing out my variables, Q is what I am solving for. My mass, it tells me right here, is a 40.0 gram sample. My C is given to me. That's my specific heat, remember? So this is for ethanol, so my value is not the same. Remember that chart where your values for your specific heats are different for every substance. So that is going to be needed to be provided for you depending on what the substance is. So my C for ethanol is 2.46 joules per gram degrees Celsius. And then we have my change in temperature. Now, if you do final minus initial on this, you would be doing negative 30 minus 50, which is going to give you negative 80. Now, since this is the change in temperature, you can kind of drop you can just drop the negative, because we're just looking at how much did the temperature change. It changed 80 degrees, so you don't need to include the negative in there. So it changed 80 degrees C. All right, let's go ahead and plug these numbers in. I don't have my Q, but I have my M, that's 40 grams, sorry. My C is now 2.46 joules per gram C, and my temperature is 80. So whether you're following along or you're double checking, make sure that you are trying to punch those numbers in on your own. So if we do 40 times 2.46 times 80, you should get 7,872. What's our unit? Let's go back and check. Grams. This should have had a degree C. See how that's important? Degree C. I am left with joules. So 7,872 joules. Go ahead and try some of these practice problems on your own. Some values that you are going to need are going to be these values here of your specific heat for water, ice, and steam, because the practice sheet that you have right now does have some problems where you'll need those values. All right, so go ahead and try some stuff on your own. Let me know if you have any problems, and good luck.